Yay! I made it to the pep rally! Mara! Misha! Woo! Mara! Woo! Misha! Woo! Oh, I can't wait to get back to math class! To do some multiplying again. All right, let's learn a little math. If you just multiplying for me, we're gonna do calculus. Ooh, oh, I want to go down and play the pep rally.
All right, hello Marauders. We're gonna learn some more calculus. We're gonna do something called the derivative, which is a fancy word for slope, okay? There's two parts to calculus. Half of calculus is all about slopes, which is really just change. Like, how is this person's height changing? The other half of calculus is all about finding areas, which is kind of crazy that if you find the slope backwards, it tells you the area. Okay, so as you know, as you grow taller, you don't grow the same amount of inches every year, and you don't go in a straight line forever and ever. As you get taller, as you get older, like here's your age and here's your height, you know, you don't just get taller and taller and taller and taller to infinity, do you? No. This is a graph for boys, I guess, and here's the ages and here's the heights. What's the slope of that line? It's like, how many inches are you growing per year? What is your change in inches from year to year? Well, the slope's always different depending on which one you pick. So here they said, well, what if you picked from this dot when you were 13 years old, you were 57 inches, and then when you were 18 years old, you were 76 inches. Wow, that's pretty tall. This is a tall person. Well, you could find their average rate of change. You could say overall, from here to here, you could say, well, the height goes from 57 to 76. That change is, let's get this here, 57 to 76, that's up 19 inches. Did it happen in 1 year? No, it happened in 5 years. So you grew 19 inches over 5 years. You could reduce that fraction to like 3.8. You're growing in an average of 3 inches every year, but actually, did you? This was more. This was a little less. What if I want to know the slope actually just right at that dot? And of course, you could do the old y2 minus y1. There it is, 76 minus 57. You could take these points. Remember, let's call this point A and call this other point B. How about that? Point A and point B. If you plug this in some rule, like f of x, you could say it's f of a. Like you plug a in, and you got 57. That's the function at a. And if you plug b in into the rule, you got, well, f of b. Just like if I plugged in x, I get f of x. So you plugged in, you have a and you plug it in, you have b and you plug it in, you get your 2 points. Okay, so here's another little graph. And so it might be a little confusing. Let me not use that. Yeah. So today we're learning slope, but using only 1 point. Before we can do 1 point, let's talk about 2 points. So here's a point A, and you plugged it in, you got some f of a. You know, there's some rule to this, and here's b, and you got that. So if you wanted a slope, how much does it change from here to here? Now remember the old slope rule that I usually don't use, y2 minus y1, x2 minus x1. So in this case, instead of calling this first point and second point, how about we just call it A and B? In other words, we'll take the y's, or this is x and y, right? And this is x and y. Isn't this our first point and this our second point? So instead of going y2 minus y1, why don't we write this? Why don't we write f of b minus f of a? That's really just the answer you get here minus the answer you get here. That's the change in the y's over the change in the x's. Instead of me writing x2 minus x1, let's just call it, you know, a and b. Let's just do b minus a. So this is a rule for finding the average slope. And you'll see this in a lot of books. And this is going to give me an overall slope from here to here. Like if I took a ruler and said from here to here. But what if I go, I really want to know the slope right there. Let's not pick this point here. Let's pick the point closer. If I pretend B's right there, I want to know the slope actually at that point with just 1 point. If I pick a point closer, well, that's going to be a different answer, isn't it? What if I got the point closer? I would be like right here. What if I got closer? The closer, oh, wait a minute, that's starting to look pretty good, isn't it? Doesn't that look like the actual slope, that one? Let's get closer. Let's get close. How close can you get? You can get really, really close. We could get out a magnifying glass and see how close can we get. Let's put B right here, like f of B. That'd be really, really close, wouldn't it? In fact, that'd be almost perfect. How close could you get? Okay, remember, make sure you read the announcement. The closest you can get is this. You might remember the smallest amount you can move. If you read my announcement, we're going to call it h. Whoa, h? H is 1 over infinity. If you got one right out of infinity questions, isn't that like getting a 0? If you made one basket in basketball out of an infinity amount of tries, you're terrible. You're almost a 0. But you did make one basket. So let's go over h amount. Okay, so I'm going to put this down. Pretend it's super, super close, like I'm under a microscope and you could just see that it's almost there. This point, we're going to go over, I'm not going to call it B. Let's go over A plus, should I go over like 0.01? No, remember that the other day, or 001? How about I go over A plus H? That's like, if this is 5, this would be 5.000000000, an infinity amount of zeros and a 1. It's over, so you have A, and we'll go over whatever the number is, we'll go over just a little bit more. And of course, you got to plug it in. So you would get, well, you'd plug A plus H into your rule. Okay, a little abstract. That's why calculus takes a little bit of thinking to get. But here it is in the book in a drawing. A lot of people like don't get it the first time. That's why sometimes we call it calculus. Okay, so here's A, and some plug it in f of A. Whatever it is, like if it's x squared, you plugged in, see what you get. And they went over a little bit. Let's go over H. So you got to pretend it's under a microscope. This is over like 0.000, like a micron over. So whatever that number is, go over a micron. Plug that in. So you got to plug in this new number, plug A plus H in here, so you get this function of A plus H. Now let's find the slope. Okay, so finding the slope, we're going to do the y2 minus y1 thing. Okay, minus and minus. So let's find the y2s. Remember, here are the y's. Okay, we'll cover those up. The second y is f of A plus H, subtract f of A. So whatever this number is, we subtract this number over the change in the x's. So we'll cover these up. We have A plus H and A. These are the x's, the first coordinates. So we'll put in A plus H, that's the first piece. I like to put a parenthesis there, minus A. Okay, so now you got this rule. And you'll see this rule. It's really kind of like this rule, but instead of calling it B, we just put in A plus H. But wait, we can break this down. The top's still the same. F of A plus H, subtract F of A. But look at the bottom. You don't know these. You don't know these because you don't know the rule to plug it into. Someone's got to tell me, you know, what is the rule for this? What crazy equation makes this? But look at the one on the bottom. Look what's down here. A plus H minus A. Wait, if you have A, add a little bit, but subtract A, won't these disappear? So all you get is H. So you're going to see next to this, you're going to put the limit. They're going to say, as H approaches 0 of some rule, f of x. So this is an x. So as U of some rule, we're going to let H get really, really close to 0. And you just got to plug this in, and you'll know the slope at that point. Now remember, you can't let H be 0 because you can't divide by 0. But you can let it be 0.0000001, which you really don't want to do. You do not need a calculator to figure this out. Let's actually try this. Okay, so we're going to try this. Here's a little bit again. These are called secant lines. As you get closer and closer, this line gets closer and closer to actually matching the graph. We call it a tangent line because remember, a tangent just barely touches. Secant cuts right through it. But as this gets closer, that's too far, too far, too far. As the dots get closer, it becomes a tangent line. The slope of the tangent line is actually the slope at that point. And so you get this rule that I just showed you. And here it is in a big box. This is the foundation of calculus. And it says m, the slope of the tangent line, is this. As h gets really close to 0, you just plug this into the function, subtract the original number plugged in the function, and divide by h. But I don't want to divide by 0.0000001. We'll just divide by 0. You can't divide by 0. Hack, okay? Here's how we're going to do it. This is kind of crazy. But I just met you, so here's my number. Okay, so here's the rule. They say, let's say this is our rule. X squared plus x. This will be the rule. We need some rule, right? And we would like to know the slope at the point 2 comma 6. I don't even have to tell you that. I just want to know the slope at 2. Now this is a parabola. A parabola. In fact, they actually graphed it down here. Isn't that nice? There's the parabola. Here's the equation x squared plus x. And we're saying, what's the slope of the parabola? If you're on a little roller coaster car here, there you are. Whee! You know, going down the ride. Okay, kind of funny looking there. And you're going down the hill, you know, so you have a negative slope, right? But as you get down here, doesn't it, the ride gets less scary? It's less and less steep. In fact, right here, the slope is 0 because you're not going uphill or downhill. Now you're going uphill. The slope's a little positive, like up 1/2. But now it's getting steeper. Maybe it's up 1/1. Maybe it's up 2/1. What is the slope right there at the point 2 comma 6? In fact, I could just say that. What's the slope at 2? We'd have to get this exactly perfect. How do you know I got it perfect? Here's how we're going to find the slope. We're going to do this math. And I say this the hard way, but remember the book looks a little scarier. Watch me do it. Okay, so here's the rule. I don't even need the graph, but I know it's a parabola. Find the slope at 2. Just add 2. They only give me 1 point. In fact, they didn't even tell me the y. So we're going to write down that rule. The limit as h approaches 0, and we write the slope. We write f of x plus h. I know before I had a, but let's call it x because I said x is 2. I could say a. I could put a, but I'll put x. It's f of x. And the bottom, we're just going to put h. And we're going to plug this in. Okay, you might say, okay, this sounds a little crazy. Okay, let's plug, we start here. Plug x plus h into this rule. You go, what? Yeah, plug that into there. So I have to do, I got to put this into there, don't I? I have to change the x to x plus h plus x plus h. So what I did is I took this part right here. I took this part right here. I plugged it in. So square this. If this was a number like 5, wouldn't you go 5 squared plus 5? If this was a 5, you just go 5 squared plus 5, 5 squared plus 5. But it's not a 5, it's a x plus h. So I put an x plus h and square it, plus an x plus h. Now it says to minus f of x. And what is f of x? This is f of x. You just copy it again. But remember, you're subtracting this whole thing. I should put a bracket here like this, x squared plus x. And I'll put a bracket here. That way I can really see the first part and the second part, the y2 and y1. So I plug this in, boom, subtract the original. And the bottom, all I gotta do is write h. Solve that. What? How do I solve it? Okay, I told you you have to be good with your algebra skills, didn't I? Okay, so we're gonna FOIL this first part. Let's FOIL this here. Now remember foiling? You could write it twice. Some people have to go like this, but you wanna be good at your foiling. It gives me x squared. hx and hx is 2hx and h squared. Okay, plus x plus h. That was the first part. Double check that, FOIL that, x squared, hx, hx, h squared, plus x plus h. Okay, minus this thing here. Let's just leave it alone. And it says all over h. Well, wow, where's the slope? How am I supposed to figure that out? Okay, at any point, and I could have done this earlier, didn't I say X is 2. There we go. Didn't I say X is 2? Why don't we change these into 2's? I could have done it right at the beginning. Sometime, you know what? I think I should start changing this to a 2. In fact, I could have did it right at the beginning. I could have just said, let's do 2 plus h minus f of 2 over h. It's still the same, but some point, at any point, either right at the beginning, you could have put 2 plus h squared plus 2 plus h, 2 squared plus 2, or you could do it later, but I think I'll do it now. I could have done it any time I wanted to. But let's since x is 2, let's change all these to 2's. Okay, so I'm going to change these to 2's. Maybe I should have just did it right at the beginning. Okay, so this is 2 squared plus 2h, x is 2, h squared, x is 2 plus h, minus, okay, this was 2 squared plus 2. I could have did this right at the beginning, or I could wait till I'm totally done. But it's at any point you feel like, I feel like changing these to 2's. Sometimes they won't tell you, okay? They just say, come up with a rule. Okay, so how are we supposed to simplify that? Now remember this here? This whole time you have to remember that you want to let h be 0. Can you let h be 0? No, you can't divide by 0. Darn it, what am I supposed to do? Our goal is to get rid of this. Let's simplify the top. Let's see what the top is. Let's break this down a little bit. I didn't say it's easy. I said this was the hard way. Okay, what do we got? We got 4. We got 2 times 2 is 4h. We got h squared. We got another 2. We got an h. And then we got this. What is this? 2 squared plus, yes, 4 plus 2. That's 6. We have a minus 6 over here, don't we? And we got this. Once again, can you let h be 0? No, you can't divide by 0. Keep going. Simplify the top some more. Let's see what we can put together. Well, let's see. We got an h squared. Let's put that first. And let's combine like terms. Here's 4 h's, and here's another h. So that's 5 h's. And let's see what else we got. We got a 4 plus 2, that's 6. Ooh, and 6 minus 6. Oh, awesome. 6 minus 6 is gone. And on the bottom, once again, all we have is h. Okay. Is it safe to let h be 0 yet? This whole time, your goal is to turn h into 0. Once you can divide by 0, you can get the answer. You can't divide by 0. What am I supposed to do? You see all the h's? Let's factor it out. Let's take an h out of there. Let's undistribute these h's like this. H times h plus 5. And the bottom is h, isn't it? Since this is multiply, you can cancel. You can't just cancel this h with a random h up here. But once it's times, you could cancel. Now, all you got is h plus 5. And remember this out here? Limit as h is close to 0. Is it safe to let h be 0? Yes, because you're not dividing by it. It's no longer there. So let's let h go so close to 0, let's just call it 0. So now it says 0 plus 5. Okay, you can pretend it's 0.0000 an infinity amount of zeros, but 0 plus 5 is basically 5, isn't it? That's the slope. The slope with 1 point. Now I said this was the hard way, wasn't it? Do you have to really do all that work? No, I can look at it and tell you the answer. And tomorrow, I'm going to tell you how to look at this question and say the answer. What? Yeah, I know that was a crazy amount of work. Here it was in the book. This is what Newton came up. And here it is. They right away said, let's turn the x into a 2. They wrote a here. We didn't have to. They said, let's just plug the 2 in right away. But this is what I did. 2 plus a, 2 and 2 squared. See, that's what I did. They combined it. They took out the h, canceled. And now it's safe to let this. And 0 plus 5 means the slope is 5. Check out the graph. Would you agree that the slope is 5? In other words, is it up 5 over 1? Would you say it's up 5 over 1? Look at it right there. Up 1, 2, 3, 4, 5 over 1. Yeah, that's the red line. It's a little bit off here because over here it's a little more than 5. Of course, if you went back 1, 2, 3, 4, 5 and over 1, see, you're not on the line. Over here, it's a little less than 5. Over here, it's a little more than 5. But right there, it's up 5 over 1. Maybe it's up 5 microns over 1 micron. Ta-da! Yeah, that took a lot of work. That has foiling. Here's one that has the square root. What's the slope at 4 comma 2? In fact, just what's the slope at 4? So like did the same thing. 4 plus h minus f of 4. You'll get good at it. You're like, hey, it's the same thing every time. So they plug it in. The square root of 4 plus h. I don't know the square root of 4 plus h. Minus f of 4. I know the square root of 4. So they said, okay, we'll take the square root. We're supposed to plug 4 plus a little bit in, take away 4. You get used to this habit. You get used to like using the rule. And then you go, what am I supposed to do? I can't FOIL that. Conjugate. Oh my God, I had to know conjugates? Yeah. A radical minus something, a radical plus something. They did it to the top, in fact. So they multiplied by the conjugate. So they FOILed this out. The bottom, they figured, let's not distribute it. Let's keep it apart. The 4's canceled. They get this. They cancel the h's. Your goal is to get the h's to go away. Somehow, there's a way to manipulate these to make h go away. You get this rule. At this point, I think it's safe to let h be 0. 4 plus 0. The square root of 4 is 2. Plus 2 is 1/4. The slope is 1/4. Awesome. Okay. I know you may not have got that all right. That's why we call calc clueless. You need a lot of practice. You'll go over this many, many times and practice, practice, practice next year. Tomorrow, next video, I'll show you how I can just do it in my head. Yes. Okay. Oops, sorry. Here's that graph. The square root of x at the point 4. The slope was like up 1 over 4. Okay. It's close, right? To here, but right here, it actually is up 1 micron over 4 microns. How they get this, they actually, oh, I won't go into the whole mx plus b thing. That's it. Let's watch tomorrow.